Hello, welcome back to yet another Armory 3D tutorial. Today we're going to talk about a wide range of topics ranging from physics to collisions and events, stuff like that. So I'm going to be explaining this as detailed as possible, so to avoid boring you with the whole 20-minute video, I'm going to instead leave timestamps in the description so you can skip to wherever you want to learn or whatever you want to see. So let's get started. Right, we have a physics system inside of Blender that is the same one we use inside of Armory 3D. It's this tab here with the physics tab. And this tab has something called a rigid body right here. So this rigid body contains information of real world proportions. As you can see here, this is 1 kilogram. And it's going to simulate what it would be like in real world if you had a perfectly flat cube falling with a mass of 1 kilogram. And we also have control over things like the collisions, so we can set this to be a box collision. Now, what is essentially important inside of Armory 3D is the fact that we don't have the 3 different types of physics that you would usually find in your average game engine. For example, Armory 3D or Godot. In this one, we only have 2. We have active and passive. However, usually you would find kinematic, dynamic, and static. Those are usually the 3 widely known sort of physics states that you would find in your game engine. In Armory 3D we have those, but they're more conglued into a single sort of thing. We have in the active tab both dynamic, as you can see here, and kinematic by just unclicking it. That's it. You don't need a whole new thing for it. It's just all in one. So some may argue it's easier. So yeah, it's very self-explanatory. You can animate things with keyframes and have them interact with physics as well. For example, a moving platform with passive. You just click animated, then you can run animations with keyframes, and it would have physics respond to that, and the collisions would move with it. So yeah, that's pretty much all there is to know about this top section. Set it to active actually. And down here we have a bunch of sort of friction and bouncing and stuff. It's very self-explanatory. You can play around with it. Essentially it describes how fast it moves and how much friction there is along the ground, so how smooth or how sort of rugged it would go. For example, scraping something along concrete is going to be a lot different than scraping it down, I don't know, a swimming pool or a slide, I guess. So that's all very self-explanatory, like I said multiple times. We also have dynamics, so you can start with your object as non-activated, so it will be static and it will only activate as soon as you you touch it with something or whatever. So we do have all these settings that most of the time they're available in default Blender, but with Armory 3D we have this extra tab that's called Armory Props, Armory Properties. So down here we have something called a trigger, and that essentially means even if we do have an active rigid body with dynamics, if we set it to trigger, it won't actually block anything. It will only it will still detect collisions, it will still move around, but it won't actively collide or block any object or bounce anything off of it. It will instead just be like a ghost. It will go through these objects. And then down here we have a continuous collision detection. I don't think I need to explain that. Instead of just detecting collisions every couple of frames, it's going to detect it as accurately as possible. And yeah. But down here we also have, before I forget, the collision filter, and this allows you to detect, or more like control, what object you're going to collide with. So if I draw an object like a cone right here, big cone, big cone. If I have this cone over here and I don't want it to actually collide with my cube because this cone is supposed to be an enemy, and I don't want my enemies to collide. These two people over here are a different type of enemy. And this is a big boss enemy, and I don't want my boss enemy to fight these little ones. I instead want them to be together. So in order to avoid them colliding with each other and thus, making your device stress out because it will have all these different collisions to deal with, instead of doing that, I still want them to have collisions, don't get me wrong. I still want these guys to collide with me, the player, but I don't want them intercolliding. So if I set them both to be... if I set this object right here to be on the second collision tab, as you can see the mass value is set to 2, the collision layer essentially is on the second. This one is well, it doesn't actually have physics yet, but if we set passive, this one is set to number 1, value number 1. So this guy isn't going to collide with this guy because that guy is on layer number 1 and that guy's on layer number 2. So essentially it's like a tunnel. You can't collide, these two can't collide because this one's above and this one's underneath. So even though they can like go through each other, they're not allowed to collide with each other in the physics world, in the physics script down here, because they're essentially, as far as they're concerned, they're not next to each other even if they are colliding. As far as they're concerned, this one's actually under this one, so they'll never be able to collide. Even though in real world, well not in real world, but in the program, we're seeing them collide. So that's essentially what this is used for, and it's very, well, it's a bit complicated to understand at start, but when it comes to optimizing your physics, it's very cool. And talking about optimizing physics, you probably will have times where you don't want all your objects in the scene to all have physics at the same time, because that will make your device stress out, and it will try to calculate the collisions for all of these different objects, whereas sometimes you only need them to have physics collisions at certain times in your game. So what if I only want this to have collisions or detect collisions when it's in a certain radius of my player? Only when it's imminently going to interact with my player do I actually want it to have collisions. So what I can do is I can grab in the collision tab, all the way at the top, I can grab the add rigid body node. And this allows me to do the exact same thing I did here, add all these different settings and properties, but directly in my node, so I can change it at runtime, which is super powerful, because if I only want this to have collisions at a certain time in my game, when for example it's fastly approaching my objects, I don't want it to have collisions when it's far away in the background, but when it's close to it and it's imminently going to collide with my player down here, then I do actually want it to have collisions. So I can set this node to be, I don't know, a cone, yeah, and I set that object to be that guy. I can set the mass, I can set all this, and you can see I can set it all dynamically. For example, if I grab a float node, I can change this mass dynamically for depending on what property my game has or different variables in my game. I can change all this completely at runtime, so it will never be the same thing. So even though I can change the settings here manually before my game runs, I can also change them in game and make them specific to the different situation in my game. So it allows me a lot more control and diversity to our rigid bodies in game, instead of having everything predetermined. We also have a lot more things to talk about, not just with physics, but we also have a bunch of collision options. Now, the two main sort of collisions that I'd advise you to know are the trigger collisions. Now, these are seemingly the most important because they do not require a rigid body, and that makes them very powerful because you don't need to have all this physics scripts, all these different stuff running and calculating collisions. Instead, you just need the volume trigger node. This one is actually a boolean, but there are two volume trigger nodes. There is the on volume trigger, and there is the volume trigger that we have here. Now, the difference between these two is the simple fact that one outputs, well, a general thing that you can add any sort of action to, and the other one outputs a boolean. Now, the boolean allows you to essentially sends a yes or no response to the question: are these two objects colliding? For example, this cube and this cone. Are they colliding? Yes or no answers only. Whereas this one allows you to add whatever you want. For example, what are we going to add? We can add an add rigid body. So this is essentially very useful because if our object, being the cube and the cone, are colliding, then we can add rigid body to our actual cone or to our to our cube, and we can change the mass of it and stuff like that and all this stuff. And there are a bunch more settings that you can do, as you can see here, but I didn't want to really drown you guys with too much information, because these are more for more advanced users. You don't really need to know any of that yet. But all this is very sufficient already, and that allows you to do collisions without actually having a rigid body. As you can see, we have collisions before we even add the rigid body. In fact, it's the collisions, the volumes intersecting, that actually adds the physics. So although these guys aren't going to fall onto each other from the start because they have no physics, when they collide, then they will dynamically move and dynamically fall. Well, currently, because we've set them to be active. But if we set them to be anything we want, we can have a completely different result. That's why the on-volume trigger is so powerful. It's the simple fact that it does not require a rigid body to actually function. It doesn't require anything other than this node. And this Boolean option, for example, you can add a if node. In Armory we call that a branch node. And this branch is going to branch out into a yes or no answer. Because like I said, a Boolean it sends out a yes or no to the question of whether or not these two are colliding, or whether or not these two aren't colliding anymore. For example, if that one was engulfed in it and it finally leaves it, for example, if you leave like the zone, like in Fortnite or Free Fire, if you leave the safe zone and you go into the storm, and then you essentially leave the collision, and that is going to allow you to send out a yes or no, that you can actually do something like you did before, like add rigid body, or literally anything you can do to this. So it's just a great way of sending out information without actually having rigid bodies, and that's very optimized for any sort of device because you don't have collisions calculated in the background. However, it's very limited. You can't actually do a lot with it because it's not precise. It only estimates a general rough sort of collision zone. It's not precise to the actual geometry of our objects. If we want precision, we have to use an on contact node. And as you can see, this category here, from this line over here all the way down to this line, these are all our contact node possibilities. See, it's a lot more than the two that we just talked about that don't use rigid bodies. The one that do use rigid bodies have a lot more information and possibility. For example, the on contact node here is essentially the same thing as the on trigger node. And we also have the has contact, I believe. Yeah, the has contact is the same thing as the volume node. It sends out a Boolean output. And as you can see, these nodes look exactly the same, for the simple difference that they do not work if you do not have a rigid body on the object. And the reason it's so different is not only just the name is different, unfortunately, it's the fact that these nodes are a lot more precise to the objects that they're assigned to. Because these nodes don't rough up the values, they don't approximate everything to optimize it as much as possible. They instead work with precision. They take all these values that we pre-assign to it, or that we pre-assign to it. I don't want to complicate things. And they use all these values to make the collisions. For example, our collision isn't going to be a convex hull, because that would be the same thing as having the trigger node, the on volume trigger, I mean. Instead, we can set something like a cone, and obviously that is a much closer approximation to our actual object. Or, this is rather a complex mesh, so we can set this one to be a box. And as you can see, that's a much better approximation because it actually surrounds the bounds of our object, which is a cube. So that will give us crisp, perfect collisions. So if we're very close and to our object and we're not quite on it yet, it's not actually going to collide with it because it's very accurate. Whereas the trigger node would probably have triggered by now because it's not meant to be accurate. It's meant to be fast. It's meant to be optimized for speed and device computability. So that's the two key difference between the volume nodes, the on volume trigger nodes, and the on contact nodes. However, these guys are insanely more powerful because you might have noticed by now they're extremely limited. You only have 2 possible collision objects, which is, pretty bad for a game. In a game you're probably going to want to detect collisions between a lot more objects, so having a ton of these duplicated around is probably not going to be very pretty or optimized or easy to use. Instead, we have a bunch of options that allow us to deal with arrays. For example, we have an on contact array, or the has array, which essentially sends out a boolean. We can go get it actually. The has array here, which is the same thing as this node, but this one sends out a boolean, a yes or no answer to the question, are they colliding? But you might be confused here because we only have one eyedroppable object slot thing here. We only have one, which means no, I shouldn't do that. I might confuse you. This one is the same object, obviously. It's the same node, and what is this RBs? Well, rigid bodies. This essentially means you can connect any sort of array to it. So arrays are essentially groups of objects. They're like a list, a bag of different objects. We have an array tab here, and we have a ton of different objects. But one that's interesting down here is the array object. Right here, the array object gives you this orange socket, just like you have an orange socket here, because this is an array node. So you can plug that in over here, and what this allows you to do is to make a huge list of objects, as much as you want. So by pressing U, you get this input socket that allows you to select objects. Select as many as you want. You can have tons and tons, and just click the cross to delete the last one. And this allows you to make a ton of different collisions instead of just the on volume trigger, which only gives you 2, or the on contact trigger, etc. You have the possibility of using an infinite number of objects. However, there is one problem. It means that every single object in your scene that you want collisions to, you have to click new, eyedrop it, click new, or select it, or whatever. You have to define it before you actually run your program. You have to define all the objects that they can collide with. How does that work with a procedural game? What if you're spawning objects directly, like any sort of game really nowadays for optimization? What if you're spawning an object at runtime and it doesn't actually exist before you run the script? What do you do then? Because you can't define it as by clicking new and adding it. Sure, there's ways to get around it, but we're not actually going to go into that. That would ruin my current excuse right here. So what we can do is we can actually add objects to an array dynamically. But no, what I'm trying to talk about is the possibility of using collections. Now, I've talked about this like yesterday, but it's really interesting. It's very useful. Right here we have our collection. Our collection is essentially everything in our scene right here. This is all our collection. I'm going to get rid of this tab, it's in my way. There we go. This is all inside of our collection over here. We have 3 objects, 1 light, and a camera. However, if I want to put this one into a new collection, I can just press M with it selected and add it to whatever collection I want. But right now I've only got 1, so let's create a new one, call it collection 2 or cone. And now we have a new collection with a new object. And if I duplicate that object, it stays in that collection, so I can build my entire world and just select things that I want, press M and move them to whatever collection I want, like cone. And now all of these objects I have inside this cone collection, I have 5 different objects, and the only objects I have in my main collection, call that main, is going to be the camera and the light. So right here I can define my cone as being the collection of objects that I want to check this cube object's collisions against. So if the cube is colliding with any object that belongs to the collection named cone, then it's going to send out, well, this message, or it's going to send out this boolean, this action. So what we can do with that is essentially build out an entire world and have as many collections as we want just plugged in to here and detect whether or not we want what we want to do with it. I'm losing my words, my train of thought here. So let's just move on. You probably get it. If you don't, then just comment and I'll explain it in the comments. Maybe. I'll try. Okay, so it's getting late. Let's talk about... yeah, we can get loads more data about our collisions. Because right now I showed you how to get collisions without rigid body. I showed you how to get collisions... or to read collisions from a ton of different objects instead of just two. And right now you can see that we have a lot more options to our collisions. We don't need to just see whether yes or no it's colliding. We can actually see a ton of different possibilities. You can detect the current friction, the current mass. You can detect all this, and you can use this information from this collision to further advance your game and customize it, like I showed you the rigid body node. Where was it? The rigid body active. No, that's not it. But yeah, you can see that again is another example. You can detect if this object has something, and if that information is you can use that information. For example, we can use a branch node like I showed you before. And you can do a lot more stuff with that information. For example, add I don't know, add a number 1 to a variable or something like that. Bump up the variable for the speed, or literally anything. I don't even know what you could do with it yet. You could do so much with all this information right here from our collisions, from our rigid body data. So, although yes, you can have a lot of different collisions, you can have a lot of different groups. In Unity, we call them tags. You can essentially apply different tags like player, enemy, finish line, car, zombie, literally anything. And these different objects that you have in your tag group, you can use them to detect whether or not your player should do a specific thing if you're colliding with that object. For example, if I'm colliding with an object, check if it's in the tag collection. If so, then do something. If not, don't do anything. We have a lot of impulse possibilities that allows you to jump, and this essentially you'd probably want to use a vector node with this, to be honest. Well, I completely misspelled that. Vector node, because this allows you to select the specific axes that you want. You can see this gizmo up here, X, Y, Z, and X, Y, Z. So you can apply different impulses. An impulse is essentially a force. And you can apply it to your specific axes based on, for example, a key press or anything like that. So yeah, that's essentially covering everything. I'm going to leave it at that because I've covered quite a lot in this video and it's getting rather long. And I never really had an actual structure for this, which I was going to have, but I ended up not doing it. You can also change a lot of things to make it physically accurate. For example, the set world gravity node. This allows you to set the gravity of the world to be something completely different. Right now, this sets the gravity to 0. For example, if I put on init, on initialization, as soon as the game starts, it's going to set the gravity to 0. If you look in this tab over here, you have the gravity value to minus 9.81 milliseconds squared, and that is the world accurate gravity. That's the gravity strength that we have on Earth. And obviously, you would want to put something like that. -9 at least, something close to it. And the important part I want to talk about here is the fact that this is realistic. You can make accurate simulations based on real world values because this is real world gravity. And obviously I'm going to get rid of this. My point is, if you go to the physics, this shows you a mass. So you can make physically accurate simulations. Well, I say physically accurate. You're still in a virtual environment, so you don't have the chaos that you would have in reality with bumps and sort of wind and stuff like that. But you can make very accurate sort of simulations. For example, if I put something like 50 kilograms with a speed of real world, it's going to fall pretty damn similarly to how a natural 50 kilogram object would. So if you want to make something similar to a real world thing, you can actually just look at what the mass of that object is, how fast it falls, how it looks, and all that stuff, and you can just put them inside of Armory 3D, and it will run a pretty damn close to accurate simulation of all of that. So it's very interesting to be able to like make scientifically accurate simulations inside of Armory 3D as well. So you don't need to just do guesswork. You can just type some, do a tiny bit of research on Google, and you can get some very easy results without spending 15-20 minutes testing out different values. That's it for me. Thank you so much for watching. I should have done this video a long time ago. I know it's probably not going to be the most easy to watch or digestible video because it's very chaotic, I think. But that's life for you. I'm not the best video producer, so I hope you enjoyed it. I hope you learned something really, because yeah, it's been a long video, and I will see you in my next video tutorial. Bye. Take care.